everyone. Today we are going to see about the addressing modes of 8085 microprocessor. Now, what is an addressing mode? So, first, in order to perform any operation, that is, the instruction has to be written. In each instruction, the programmer has to specify three operations. That is, three things. So, first one is the operation to be performed. That is, what type of operation, that is, whether it is an addition or any data transfer or subtraction or any logical operation. So, whatever it may be. So, first we need to give what is the operation to be performed, and the next one is operand. Operand means data. That is the address of the source data and the address of the destination. Source means from where it starts and destination is where it ends. So the address of the source data and the address of the destination data should be specified. Now, what is an addressing mode? So the addressing mode is the way the operand is specified in the instruction. Operand means data. So how we are specifying a data in an instruction, that is called an addressing mode. So the method by which address of source of data or the address of destination of result is given in the instruction is called addressing mode. Here we have 6 general purpose registers, that is B, C, D, E, H and L, and A is a special purpose register. So A is an accumulator. So why it is called a special purpose register is, for any arithmetic and logical operation, one data should be in the accumulator, and after performing the arithmetic and logical operation, the result is automatically stored in the A register. So that is why it is called a special purpose register. So the other 6 registers, that is B, C, D, E, H and L, are general purpose 8-bit registers, meaning they are used to store 8 bits at a time. And we have register pairs also. So here these 6 8-bit registers, that is the general purpose registers, are combined to form register pair. So here the combination is BC register pair, DE register pair and HL register pair. So these are the 16-bit registers pairs. And normally we know that the memory address is 16-bit. Now, in 8085, we are having 5 types of addressing modes. The first one is immediate or implicit addressing mode, the register addressing mode, direct addressing mode, registered indirect addressing mode, and the implicit addressing mode. So the immediate addressing mode. So in this mode, the operand, that is the data, is specified in the instruction itself. For example, move immediate B, 45. So normally in the instruction, if I is given in the instruction, then it is called immediate addressing mode. This I stands for immediate data. That is, the data is available in the instruction itself. So for any 8-bit data, we need to use MB. Okay, so MBI means MB stands for move and I stands for immediate data. So move the immediate data 45 into the B register. So after execution, what happens is B is having the data 45. Okay, so after executing the instruction, the B register will be having the data 45. Now, the other instruction is LXI B, 4500. So normally this X represents register pair. So here I am having 3 register pairs. What are they? BC, DE and HL. So register pair means it is, if it is given as D, it is not B, it is BC register pair. So L stands for load, X stands for the register pair. So what is the meaning for LXI B, 4500 is load the immediate data 4500 in the BC register pair. Okay, so this 4500 is 16 bits. So what will happen is in B, 45 is stored, and in C, 00 will be stored. So after executing this LXI B, 4500, the register pairs B and C will be having 4500. Now, the next one is direct addressing mode. Now, what is direct addressing mode? So here, the address of the data is given in the instruction itself. That is called direct. That is, the address is given directly in the instruction. So normally, we'll be having an 8-bit. That is, the data is 8-bit and the address is 16-bit. Okay. So here, I have given the instruction LDA 4500. So what is the meaning for LDA is load the accumulator with the content of 4500. For example, before execution, the memory 4500 is having the data 25. Now this 25 is loaded in the accumulator. So after executing this instruction, the accumulator will be having the data 24. So here LDA is the operation, 4500 is the address of the source, and accumulator is the destination. The next one. Register addressing. So now what does register addressing means? The data is present in the register. So the data normally, what is data? That is called operand. So the operand is the general purpose register. So here the instruction is move B, H. So here the data is in the register. Okay. So here move B, H means the content of H is moved to B. So here H is the source and B is the destination and move is the operation. So after execution, the content of B becomes 3C. Normally before execution, supposing in register B, I'm having the data 2A and in H register, I'm having the data 3C. Now what will happen is this 3C is moved to B register. So after execution, B is having the data 3C. The next one is register indirect addressing mode. That is, the data is specified indirectly. That is, the address of the operand. The address of the data is specified in a register pair. So normally, if your instruction consists of an M register, meaning that M is a register, memory register, whose address is specified in the HL register pair. So you always remember that M is a memory whose address is specified in the HL register pair. And here move is the operation, M is the source, and B is the destination register. So before execution, HL register is having a data 4500. And in the 4500 memory, if you are having a data 25, that is moved to B register. So after executing this instruction, that is move B, M. So M is a memory and the address is specified in HL register pair. So we have to go and search for HL. Supposing in HL, I'm having the data, that is the value. It is not data. H and L is 4500. This is the address of the data. So in the 4500 memory location, I'm having a data 825, which is an 8-bit. So that data 25 is moved to B register. So after execution, this B register will have the data 25. The next one is implicit addressing mode. So implicit means here the address of the data as well as the address of the result is fixed. There is no need to give the address specifically. It is understood. Okay. So for example, this is the instruction. CMA is the operation. CMA means complement the accumulator. So here A is the source and that is A is the destination, meaning that whatever the content stored in the accumulator, that is complemented, and again the result is stored in A register itself. So that is called, it is implicit addressing mode. The next one is CMC. So CM means complement, C stands for carry flag. So carry flag, it is a 1-bit register. So CMC means complement the carry flag. And it is understood that the carry flag is complemented. That is no need to specifically give the address of the operand. It is understood. That's why it is called implicit or implied. The next one is STC. STC means set carry. And RAL is rotate the accumulator left with carry. So normally whatever the content of accumulator, that is rotated towards left with carry. So here the address, that is the source is accumulator, the destination is also accumulator. Okay, then RLC means rotate accumulator left without carry. So it is also, we understood that the content of accumulator is rotated left without carry. So the source operand is in the accumulator, and after performing the operation, again the result is stored in the accumulator. Okay, so in these 5 instructions, that is CMA, CMC, STC, RAL, and RLC, it is understood where what is the address of the data and the source data and the destination data. So we no need to give any operand that is specifically give the address. Okay, it is understood from the instruction itself. That is why it is called implicit addressing mode. So in this video, we have seen the addressing modes of 8085 and its type of 8085 with examples. So thank you for watching this video. Thank you.